I'm working with Final Spark on bio-inspired computing. We are trying to build computers from living neurons. We know that neurons are around a million times more energy efficient than digital computers. We don't try to really interfere in any way like with the human biology.
Right.
So we don't try to change humans. That's not the purpose. We try to build computers from the biological materials. We think that the future looks like that we can build something much bigger than actually human brain. So maybe it will be much more intelligent or will have much more capabilities.
Dr. Ewelina Kurtys, thank you very much for joining me on Success Matters podcast. I came across your profile on LinkedIn and I was very intrigued by what you do around bioengineering, biocomputing. I don't actually know what the right term is. How did you get into this field and what was it that led you to where you are today?
So thank you for the invitation. So I'm working with Final Spark on bio-inspired computing. We are trying to build computers from living neurons. And how I started? Well, I started from biology side. I did PhD in neuroscience,
right.
And I was always fascinated with anything related to human brain. And later, when I left academia, I started to work on software with software companies on commercial side, of course, but on technology. And then this is how I discovered artificial intelligence, and I became very fascinated by this. I went for many conferences and meetups and tried to learn as much as I could. At the time, I was living in London, so it was a very good opportunity. There were a lot of nice conferences and meetups about this. And this is how I also discovered the next frontier in AI. So how this can develop further, so that people are trying to do some unconventional computing, which is some new way of computing. And one of this is computing using living neurons, which is great combination of what I like, neuroscience and engineering.
Right.
So this is why I'm on this project.
Okay. So there's a lot there. Living neurons. Where do you get these living neurons from?
We get them from human skin. So this is a very nice opportunity now. It's possible since around 15 years to get huge amounts of neurons in the lab with no sacrifice. Before it was usually scientists were taking neurons from rats or mice directly from the brain. And now it's much easier. You can just take human skin and you can transform the skin cells into stem cells, and then from the stem cells you can get anything you want. So you get something like induced pluripotent stem cells is such a technical term, and from these cells you can transform them, for example, into neuron. And so this is actually great because we can get a huge amount of neurons in the lab. That's not a barrier. So this would be great advantage compared to, for example, silicon hardware, where it's quite difficult to manufacture this, and sometimes manufacturing is limited by the resources. So in case of neurons, there is practically no limit in how many you can produce in the lab.
Okay, and is there an advantage to using human neurons versus rats or pig or other animal neurons?
Well, at this stage of the development, I think it doesn't matter. But we believe that in the future it matters because we think that neurons at the end will be better. Human neurons will be maybe more suitable to process some advanced information. But this is purely hypothetical. But yes, we use human neurons because it's actually so easy, because you can get human skin and there are procedures to get neurons from this. So this is also, at this stage, actually, that's the easiest option.
Okay. It sounds very sci-fi and futuristic here. Is there any risk that you could have, like, I don't know, eugenics? We've heard of eugenics, right? Where people select different characteristics or traits to try and breed that. Is there an element of that possibly coming in this field of neurocomputing, biocomputing?
What do you mean by? Can you?
Well, I was just thinking out loud here, where you had this sort of scenario where you've got people trying to breed a super race, right? That's maybe the best way to
Oh
describe
yes,
it.
absolutely. I get what you mean. Yes, but actually, that's yes, absolutely. There are projects like that. Maybe not in Europe, but definitely people try to genetically modify humans also,
Yeah,
and I'm sure it will be done in the future. I'm sure somewhere, but that's not absolutely the objective of our project because we only use building blocks from the brain, which are neurons, but we do not try to make brains.
right,
So it's like using bricks. We don't try to, you can build a different type of buildings, but the common thing will be only bricks. So in this case, also, we use only building blocks, neurons, but there is nothing. Actually, there is no connection with the human brain. Let's say we don't try to reproduce this, and also we don't try to really interfere in any way, like with the human biology.
right.
So we don't try to change humans. That's not the purpose. We try to build computers from the material, from the biological material. So that's a bit different direction.
Okay. So how does the biological computer work? How is it different to a regular computer with you're using a computer now, I'm using a computer now to have this conversation? How will a biological computer be different?
Well, we know for sure it will be much more energy efficient. We know that neurons are around a million times more energy efficient than digital computers. And at this stage, we cannot compute too much. We could store 1 bit of information in our neurons in the lab. So that's very early stage. But by looking at the human brain, we can have some idea of what neurons can do versus digital. And apart from the energy efficiency, we know that neurons, completely different. They are completely different mechanisms in information processing than digital. Because neurons they code information in time and space, so that's totally different. It works totally different. We know for sure the coding of this will be totally different approach, and we also know that brain is very efficient, of course. And why it's efficient is because, for example, it has memory and processing information in the same place, so it saves energy. We can also know that the brain doesn't analyze all the information in the same manner. So we are filtering a lot information. And there are some things which we analyze with details and some things which we don't.
Hmm.
And that's very important also in contrary to computers, because computers usually they analyze a lot of data with the same importance. So that's a different attitude and a different mechanism of computing. So these are we can know for sure that it will be different, and also we don't want to replace computers, digital. We rather think that all these new technologies, also quantum computing, anything new, will be complementary, because all of these technologies, each of these, will be good at something. So we believe that living neurons will be good at tasks which are done today on the digital neurons, because we think that biological neurons will be better substrate for that. But of course, it's assumption. It has to be proven in experiment. And we think that it will be great addition, complementary to the digital technologies.
Right. Okay. So artificial intelligence, where we started this conversation, are you creating artificial intelligence machines using these biological neurons? And is that artificial intelligence coming like naturally as a result of the fact that you're using human neurons, or does it need some sort of programming within it? How does this all work?
So for the moment, we keep our neurons on the electrodes. So we can send them electrical signals and we can receive a response. And because neurons are communicating using electrical signals and chemical signals, we can also release some chemicals in the medium, so in the liquid in which neurons are placed. So we can communicate with neurons in that way. So for sure, it will be totally different approach for programming. At the moment, everything is connected to the digital hardware. So we can program in Python what should happen with the cells. So which kind of simulation, when we should collect data. All this is programmed. But the way how we interact with neurons, of course, will be different than how we interact with digital hardware. But this still has to be discovered. So at the moment we do a lot of experiments, a lot of trial and errors, and we try to figure out what is the best way to communicate with neurons.
Right. Okay. This is all very, very fascinating stuff here. That's at least for me, I'm a bit of a nerd and a geek when it comes to this sort of thing. When you were growing up, did you imagine you'd be working on something like this at the time, or did you have different plans for your life as a young schoolgirl?
Well, I always wanted to do something special. And always when I choose projects, I always have to see this as something special and something great. And when I was a child, I wanted to be scientist because I was fascinated with this, with
Okay.
these kind of things. I liked chemistry also a lot. But after I went more into biology, I studied pharmacy and biotechnology. So yeah, I was always fascinated. And then when I started to work in the lab, I was really fascinated because it was like a child playing with toys, because experimental biology is a lot of equipment. You have a lot of stuff to play with, a lot of machines, and this is a lot of fun. So yes, I always dreamed about this. But after some time I get tired. So I wanted to work also in industry. I wanted to see something else. I was curious about what is outside academia. So at some point I got tired with experimental biology and I moved outside
Right.
to the real world.
Okay. So the experimental biology was also part of your neuroscience
Yes,
PhD.
yes. I did my PhD. Yes, it was purely experimental on cells in vitro or also on animals. I did
Right.
a lot of medical imaging. So I did very nice stuff with non-invasive imaging. So you could see inside the brain without opening it. So that was very, very cool, very nice. And this is why actually when I transitioned to industry, I learned about AI, because my first job in industry was for medical images analysis. So
Right.
this is a field where a lot of artificial intelligence is used, because in industry you have a lot of data, and people try to search for ways how to analyze this data automatically, so that we can save time, and also it's actually often more accurate. So this is why how I learned about artificial intelligence in the industry.
Wow. So I was listening to a podcast earlier today about artificial intelligence, and the lady, the guest, Karen Ho, she was talking about how these big machines that are being built for artificial intelligence don't necessarily need to be so big, because they're trying to solve for so many things, and potentially, you could create AI machines that are much smaller, that are therefore more specific tasks. Is that
Yes.
kind of the aim that Final Spark has? Is that the kind of way in which you're planning on, developing your machines, your kind of living machines, I suppose?
No, actually, no. We don't hope for this narrow specialization. We
Okay.
actually hope for general computing. And our dream is to build huge bioservers. So at the moment, our laboratory is small, but you can access remotely for doing experiments. And we have scientists from all over the world who are doing experiments on our cells remotely. And the same way we imagine the future, that we would like to have huge bioservers where people will be able to connect remotely, as today we are connecting to the cloud computing, and they will be able to access this computational power. So we actually plan to try to build huge structures of neurons, because, as I said, it's very easy to get huge quantities of neurons. So we would imagine even 100 meters of tissue, all with the living neurons in the lab. And in such central laboratory, it will be easier to handle this very fragile material, because living neurons are very fragile. They need very specific conditions to be alive. So we think that the future looks like that we can build something much bigger than actually human brain. So
Right.
maybe it will be much more intelligent, or will have much more capabilities. So that's how we imagine. But of course, there are people who are also trying to make edge or little devices.
Yeah.
Our competitors from Australia, Cortical Labs, they actually released some prototype of computer which is portable with living neurons inside. So they believe in a bit different direction. We also have competitor Koniku in the US, and they tried also with little devices. Actually, that was kind of like edge computing, really on the edge. but they tried actually to use living neurons for a very specific task, which was detecting of chemicals in the air.
Right.
So it's actually very narrow task, maybe not anymore computation in the way how we see computers.
Okay.
But we believe in general computing, and we believe in Final Spark believes in huge bioservers.
Right. Okay. So for those listeners who aren't in the tech field, in the way in which you and I are, what do we mean by artificial intelligence? What do we mean by edge computing? And how do you keep a living neuron alive in a computer that's going out in the field?
Okay, these are very different things from different
Yes.
areas. So artificial intelligence, I see this like anything what can be done by the machine. So even if we use a smartphone with a Google Map, I think this is artificial intelligence for me at least.
Mhm.
And of course, there is specific field which is machine learning, which are the algorithm of which people are talking most of the time when they think about artificial intelligence. And these are specific algorithms which are actually neurons, but digital neurons. Neural networks which can learn with the data. So that's actually is called machine learning because when you put the data, you actually change the connections between neurons and they learn from this data. So that's why it's machine learning. But actually artificial intelligence, I think is not only this. I think it's anything what can be done by the machine. So that's first question. Second question was what is edge computing? Is something what we don't do. But I just mentioned this as a to mention competitors' work. So edge computing is when you make very small devices which you put everywhere. It can be sensors, for example, any kind of which you want to have, for example, to measure CO2 level or temperature or anything like that. So there are little devices. There are a lot of efforts in this, but that's not our field.
Mhm.
And then also how we keep the cells alive. Yes.
Yes.
So how we keep cells alive? So in the lab, we have to try to reproduce as much as possible the condition in the body because that's a natural condition for the cells, and it's very difficult. So this is why cells in vitro usually they live shorter because. We know that living neurons can live in even 100 years because those which we have in our heads, they usually are for our lifespan, most of them, because most of the neurons don't divide during when we are adults. So they can live very long, but in the lab is very difficult. So we have a success of 3 months, which is very long for the industry standards. But it's very difficult because it's always it's always a bit different environment there on the electrodes. It's not the same as in the human tissue. But we, of course, have to keep the stable temperature, pH, even the light, everything actually, even small vibration.
Mhm.
When we move the equipment in our lab, this can also affect the activity of neurons. So we have to be very, very careful because neurons are particularly fragile for any changes in the environment. So I've seen some research done in other labs where they show even the changes in the activity of neurons due to changes of temperature. So this is amazing. Even 1 degree Celsius difference can change the activity of neurons.
Mhm.
So it's a very fragile material.
Yeah. So these companies that you mentioned, a couple of
Mhm.
companies that are making computers that can go to the edge, right? So be
Yes.
sat in, midway between, say, your computer now and
Mhm.
a cloud computing platform, but doing some work there. How are they making sure that those neurons are okay when they're moving that equipment out to the field or moving it to another, the location?
Oh, the same way. There has to be heating inside
Yeah.
and everything, pressure. I think it's much more difficult
Mm.
than inside the lab, of course, because
Yeah.
when you move something, you always have some vibration, so it's a little bit difficult.
Hmm.
So I'm sure they need a lot of things to protect cells from any kind of vibration changes in temperature, but they need to get everything the same as they get in the lab to
Right.
survive.
Okay. This is such a fascinating field, Ewelina. It's like a really, really like bleeding edge of science, right? To use the neurons for computing and computing capabilities. You said that you managed to store 1 bit on a neuron. Um, when we think about the human brain, how many terabytes of data do we store in our bodies, in our human brain, and across our neurons? Is there something anyone can even measure?
I don't know, honestly. I think I've seen some paper where people try to reproduce the function, the activities of human brain, and they use a little nuclear plant for that to provide the energy. So after the energy side, I know, but I think it's hard. I don't know how many bits are in the brain, but we know that there are trillions of connections between the neurons for sure.
Yeah. So if you took trillions of connections as representing at least one bit, then that's 3 trillion bits, or and then on top of that, the combination of the different connections leads to different outcomes, right? So that's even more. I mean, who knows? Who knows how big it is? But that's fascinating conversation. So as you know, Evelina, this podcast is called Success Matters, and I set it up because when we think about success, oftentimes it's about what's presented to us as being successful. It's sometimes the material things, those sorts of elements. But of course, there's always more than just that. So what does success mean to you?
So for me, the success in life is to get what you want from life, and that's really successful, I think. And there are many steps needed for that, because first you need to know what you want actually, and that's very difficult. And I think it's really important not to look at other people, because everyone has his own priorities, and it's really important to look inside yourself what you really want, because we have only one life, I believe, and it's really a pity to waste this to chase dreams which are not ours.
Yeah.
So I think it's really important to understand what you really want, and then to try to get it. So that's a real success for me.
Okay. And so have you determined what you really want? What's important to you?
Well, I think what is very good, of course, you have to follow your passion and your excitement, because sometimes you just feel it, that you come across something and you just feel this is great, this is for me, and so I think that's really important. And another thing is, I think it's very good to do a lot of trial error and to do a lot of little experiments, because especially when you are young, because then it's quite easy to make changes in your life. So, for example, when you are a student, it's really great idea to go to some international exchange, because if you don't like it, after a few months you are back home and you don't have to do this anymore. When you are the older you get, the more difficult and it might get to make changes. So it's good to try a lot of things. And if you don't like something, then just to move on and do something else, because until you are happy, I think that's very important.
Okay. And so that's kind of the scientific principle in many ways, right? You try something out, you experiment with it. Maybe that experiment works, maybe it doesn't work. It doesn't work, you move back to where you started. And if it works, then you carry on building upon those experiments. I can kind of see that and how that works. And would you say you're continuously experimenting in your life then?
Yes, I think so. Yes, I always try to follow what I really want. And I hope it works for me. I think it works.
Well,
Yes.
I mean, if you've come a long way, right? You did your PhD in Groningen, and you're now in Cambridge working for a Swiss company. So talking about just that international travel aspect of trying things out, you're clearly doing something good there.
Yes, I always wanted to travel. Yes, that was one of my dream actually. And I also did this little experiment when I was a student. So that's why I said it's really good to do these things when you're young. So I went abroad to see how it is, and if I like it, and I did like it. So I also tried to live in different countries. I lived in Belgium, in Italy, in the Netherlands, and now in the UK. So I could see what are the differences, where is the best place to live. So I think this is also good to test, because countries are very different sometimes, and sometimes they provide totally different opportunities, infrastructure, and these are really important things to check if you want to have such a life for long.
Yeah, that's true. And also sometimes we have an impression of a country rather, based on, what we see from the outside. But when you go there and you live in there, not as a tourist, but you actually live there for a while, you realize what's good and bad about it. Maybe your perception is different, right, to what
Absolutely.
a country was like. So that's interesting. So I have a tradition on my podcast that I ask a previous guest a question for my next guest. And keeping with the sort of sci-fi type theme that we have today, um, one of my previous guests asked, we talk a lot about, people's superpowers,
Mhm.
um, but what is your kryptonite? And just in case you don't know what kryptonite is,
I don't know.
it's a, I've come to notice this because I've asked this question once before to someone else, and it's kind of an age thing as well. I think you have to be a certain age and you have to have been from a certain demographic.
Okay.
So Superman, the cartoon and movie series, um, Superman, comes from another planet called Krypton, and he's got all these superpowers. But there's one thing that kind of holds him back or drains his powers, and that's called kryptonite, which is a crystal that comes from the planet Krypton. And if he's exposed to it, then his powers start to drain. So, what is your kryptonite? What is it that drains your power, your drive, your capabilities?
So you mean what drives me, or what is my power?
So what is your power, but then also what takes away that power from you?
Oh, that's good question. So my power, well, I think my power is flexibility, but I see this such a way because I like to design life and everything so that it's flexible.
Hmm.
Because I think, especially today, we really cannot predict the future, and I think we always should keep this in mind that there are a lot of things which we cannot predict. I was recently, I love the books of Nassim Taleb, which is great. He's a mathematician and trader, and he wrote a book, Black Swan. For example, I was just reading this recently. So this is really great approach to life, I think, because he writes about these events which are like black swans is something which we thought will never happen. And very often we cannot predict what will happen or the magnitude of what will happen.
Yes.
So, like, for example, with COVID, nobody could predict this, or at
Mm.
least most of the people couldn't see this coming. So I think this is very important to be flexible and always learning. So that's my approach, at least. What takes away energy from me?
Yeah.
Slow process and
Okay.
bureaucracy. But that's why I live in the UK, because I think this is fantastic place because there is a minimum bureaucracy. I love that. So that's one of the reasons why I enjoy England so much because every kind of like slow process, it's something what drives me crazy. Yes.
Right.
And it takes away all my energy.
So it's okay. So slow processes. So yeah,
Yes.
bureaucracy can be the killer of
It's
things.
not my thing. Not my thing. Although I know it's necessary sometimes, but it's not my thing. No.
Yeah. And it's interesting your perspective that the UK isn't overly bureaucratic.
At least
Um,
compared to Poland, from where I
right.
come from.
Yeah.
So
From where you come
compared to Poland, you have a minimum, and this is so fantastic because it allows you to focus on important things,
from. Yeah.
not on some paper. So I love that really.
Yes, and yeah, I work in my day job. I have an international role, so I recognize that bureaucracy, whilst it may appear to be bad in one place, is actually better than it is in other places. Doesn't necessarily make it good for everyone, but it's a good point there. So Ewelina, do you have a question for my next guest?
Yes. So actually, I have very technical. I don't know if it's good one, but okay.
Okay.
I'm always curious because that's a question which I'm asking actually many people when I meet them. So how do you use AI in your work, if they
How
use
do
at
you
all?
how do you
Artificial
use
intelligence.
AI in your work? Okay.
Maybe someone who doesn't use it at all, but I'm always very curious how people see this, how
Yeah.
it's changed the work of people.
And how do you use it?
Oh, well, I do use a lot because, I work mainly with words because I work on commercial sites. So, I'm talking to investors or sometimes to podcasters.
Yeah.
So it's all about talking. So sometimes I ask ChatGPT to help me to write something, some emails, but not really often. But sometimes, especially if I have to write something what is hard for me to write. For example, if I'm angry with someone, that I can ask ChatGPT, write this as you wouldn't be angry. So
Yeah.
especially. I think especially for things which are not natural for you, but you should do them in some
Mhm.
cases, that's very helpful. Then also for some kind of research, when I have to search for some complex information, I think ChatGPT is saving a lot of time because that's much more than just Googling. It can summarize information for you. So yeah, it can speed up a lot. But of course, always have to be careful because it hallucinates a lot.
Yes.
So of course, I do this only for research, which is not really crucial. So, if I make some mistake, okay, I can figure out quickly. So if I have something important, then I wouldn't use it for some
Mm.
important decision, let's say.
Yeah, and I mean, I've been using ChatGPT a fair bit as well. Primarily, well, similar to you, sometimes for words, because I might write something thinking it makes perfect sense, but, someone else reading it would think, hang on, what is he going on about? So it's a way to sanity check and make sure that it does make sense, because it gives you a more neutral perspective than,
Absolutely.
maybe the way you're looking at it. And also I've been using it to actually help me with my podcast, because I've asked it to analyze some of my podcasts and give me some enhancements to them that
Absolutely.
I could
That's
look
great.
at. So it's giving me that. But of
Mhm.
course, we're only scratching the surface of what AI tools are capable of doing, right? And I was reading in preparation actually for today's conversation, I was reading actually watching a course on the cost of AI,
Mhm.
and because AI, it's very simplistic in the interface that you have to it, right? ChatGPT or Google Gemini or Perplexity or whichever AI engine you use. You type something in and it comes back with an answer. But behind the scenes, it's very, very complex. You've got these really powerful chips that need other
Yes.
chips in front of them to process what's coming into them. And you need all this different memory, and you need huge amounts of RAM, and you need all this. And then you realize it's a really big thing that's sitting in the background
Mhm.
that's taking a lot of power. So it's a fascinating area, fascinating subject. And I think we're only just scratching the surface of what AI is capable of in our day-to-day lives.
Yes, I think it can automate a lot of especially repetitive tasks. There
Yeah.
is no doubt for that. Of course, yes. So I think it's good to use it, at least to try to use it, because those who will use it will have advantage over those who don't, because
Yes.
it can increase the output significantly.
And interestingly, the guest who asked the question about your kryptonite,
Mhm.
his name is Chris Luxford, and he's a business consultant. He actually is using AI a fair amount. And then one of the things he said about AI is, people, there's kind of two camps, right? There's one which is they will use AI in the kind of lazy manner. So they'll just put something in there, get it out, copy and paste it, and off it goes to wherever it's going. But then there'll be those that question AI in a way in which gets a much deeper and richer answer, and they're using it, their wisdom, in effect, on the wisdom of AI as well to get a deeper answer. And that I thought was quite an interesting perspective to have around AI as a tool.
That's interesting. Yes, I heard also that a lot of iteration is good because yes, you can get better answer definitely.
Yeah, yeah. Okay. Well, this has been a very, very fascinating conversation, Ewelina. We're towards the top of our time now. So if people want to get in touch with you to find out more about the work that you do or Final Spark does, what's the best way for them to contact you?
So LinkedIn is great idea, and also our website finalspark.com.
Mhm.
You can see team section, and there you can find emails of everyone, all the team.
Right. Okay. All right. Great. Well, thank you very much for appearing on Success Matters, and wish you all the best with developing these new biological computers. I don't know what's the right term. What should I be calling them?
Well, at the moment we have several. Yes, biocomputer, biological computer. We also have more technical term like wetware computing. So
Wetware
yes,
computing.
wetware. Yeah, because it's a new field, so usually it
Okay.
happens that there are different words and it's not established yet. So
Yeah.
in the papers you can see, or in the press you can see different vocabulary for the same thing.
Okay. All right. Cool. Well, great. Thank you once again for appearing on Success Matters.
Thank you so much.
To find your success, contact me at info@successmatterscoaching.com. That's info@successmatterscoaching.com.